Let's dive into two types of numbers that shape our world, the rational and the irrational.
So, what if some numbers just go on forever, but they never, ever repeat a pattern?
Okay, think of this as our map. It's the entire system of real numbers we're exploring.
All right, let's start on familiar ground. We've got naturals, wholes, and integers, the numbers we see every day.
But check this out. These are all part of a much bigger, super organized family.
And that brings us to rational numbers. The big deal? You can write them as a fraction.
So their decimals are always predictable. They either stop dead or they repeat a pattern forever.
But here's the question. Does this tidy little system really cover every number out there?
And plot twist. Turns out, some numbers just refuse to be written as a simple fraction. Meet the irrationals. Their decimals ramble on forever, with absolutely no repeating pattern. Wild, right?
You've definitely met some of these guys before. Think pi, or the square root of 2.
But how can we be so sure? How do we actually prove the square root of 2 is irrational?
We use a cool method called proof by contradiction. First, let's pretend it is rational. So we'll say root 2 equals a fraction, a over b, in its simplest form.
But if you follow the logic, it means both numbers have to be even. That's a contradiction.
Okay, so we've met both types. Now let's see what we can do with them.
Want to find a rational number between two others? Easy. Just find the average. Add them up. Divide by 2.
And what's crazy is you can do this forever. There's an infinite number of them in there.
All right, another cool trick is called rationalizing the denominator. It helps clean up messy fractions.
You just multiply by something called its conjugate. And poof, the square root in the bottom disappears.
So, we have these two totally distinct families of numbers. Let's recap and see the big picture.
This table lays it all out perfectly. The key differences side by side. Super clear, right? And when you put them all together, rational and irrational numbers make up all the real numbers.
That's right. Their union creates the entire number line. Every single point is covered. No gaps.
So that leaves us with one last mind-bending question. Which type of number is actually more common?